So another thing I want to show you is the route tables down here. If I click this one, it's the same idea again. You can go to the dashboard and come back here. Again, we have a default route table for our default VPC. So as you can see, because I've named it default VPC, now we can see it. So we have one route table by default, and it is technically assigned to the default VPC. I'm going to give this one a name also. So this is going to be default route table. If I go down here, you can see there is something like a properties of this object, this resource down here. So we have the summary, so we have the route table, this is the ID, and this is the name that I've just given it, an associated subnet to it. It's 0 subnet right now, and the VPC. If I go to the routes, you can see that one of the destinations is just the CIDR range of the VPC, and another one is just the default route to 0.0.0.0, and it is going to a target which is IGW, which is an internet gateway. So as we know, by default, when we are working in a default VPC, we have public internet access. So that's why the reason that we have internet access is that we have a default route to an internet gateway by default, and it's active. So that's why we can hit the internet. If I take a look at the subnet associations here, this is the default route, and it says you do not have any subnet associations, but the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So don't forget this. This is pretty important. By default, any subnets that you have, it is going to associate with the default route inside your VPC. So it means that they have internet access right now, although they're not associated with anything, but by default they are associated with the default route and with the main route table, and they have internet access. So this is one thing that you have to always remember, and you have to create, I believe that you have to create your customized VPC subnets and route table and internet gateway and start configuring your resources inside your VPC. Do not use the default one, because there are some default configuration for them which they may be a problem for the security. I mean, it's not really safe all the time to use them. So my suggestion is to create your own VPC. Anyway, so I'm going to show you one last thing, and it's internet gateways here. If I click on internet gateways, you can see we have one internet gateway by default, which is it is already attached to this default VPC that we have by default. So I'm going to name this one also same thing, default internet gateway. So if I go back to the dashboard, I went through the VPCs, subnets, route table, internet gateway. The remaining part is network access and security groups. Let's take a look at the network access list also. So we have a default one which is associated with the default VPC and our subnets also. So I'm going to give it this one a name also. It's going to be default network access list, NACL. One thing that I want to emphasize here and I want to show you is that we have inbound rules and outbound rules, right? This is a network access list. So if I take a look at the inbound rules, by default it's allow all traffic. There's no, I mean, there's a deny, but there's an allow all at the top of this rule. It means it's wide open by default. Inbound rules and outbound rules, both of them, they're wide open. So don't forget this. These are all subnets that by default AWS created for us, but you have to know that by default you have a VPC which has a route table to access to the internet wide open, because there's no nothing inside the network access list. This is one thing that you have to always remember. And if I go to security groups, you can see that by default also there's a security group assigned to associated with my default VPC. And I'm going to give this one also the name like default security group. And there are inbound rules and outbound rules here. If I click on this one, it says all traffic, it's allow from the source, which is the this one, this is a security group. And outbound rules, it's the same idea. It's to destination 0.0.0. It means all traffic it's allowed to go out. So if I take a look at the inbound rules and outbound rules here, it means that they're all wide open. So This means that we can easily spin up resources inside the VPC. We can have internet access, and we need technically to prevent the access to the instances directly by a security group, which we can assign it directly to the resource like EC2 or other resources. So here, if I go back to the dashboard, then everything is wide open and we have all of our resources ready to use. So as you can see top here, we have a launch VPC Wizard, and we can create all of these resources manually. For now, for the purpose of demonstration, I'm not going to create anything here, and I am just going to show you a diagram about how the VPC subnets, route table, internet gateway, network access, and security groups is working together in a big picture. And then I will move forward to the compute part and start spinning up virtual machines or EC2 instances in the AWS. And then after a while, when we go through the course more and more, and when we understand the services and features inside AWS more and more, then we will come back here and start working with all of these features here. Even down here, the VPN connection, and we can extend our VPC to on-prem data center, and I'm going to connect my on-prem servers to the AWS, and we will see that we can easily see each other and communicate with each other. So let's then go to a diagram. So I have this diagram here. Let's take a look at this one together. So as you can see, this is the AWS, and this boundary here, this is the AWS, and inside the AWS we have our own VPC. So the second boundary here, this one is our VPC. It's our virtual private cloud inside the AWS services. So it's like a data center. It's like a virtual data center that we can do whatever we'd like inside the VPC. Then inside the VPC, we have, for our VPC, technically we have a CIDR range. In this case, in this example, we have 172.30.100/16. This is our CIDR range for the whole VPC. And then inside the VPC, in this picture, in this example, we've created two different subnets. Subnet 1, which the IP address range or site is 172.31.00/20, and this one is 172.31.16/20. So there are two different ranges. The subnets are different. So we've created two subnets, one here and the other one here. So we have two different subnets inside our VPC. And as you can see, each subnet is in separate availability zone. And this one is in availability zone A, and this one is in availability zone B. And you have to know that subnets, they are restricted to each availability zones. You cannot have one subnet across two or more availability zones. Each subnet are inside one availability zone. So that's why we have subnet 1 in zone A and subnet 2 in zone B. In here, as you can see, we have a router inside the VPC. This is inside the VPC, but outside the subnets, right? And the route table here, the main route table, is also, it is connected to both of them, and it is something above the subnets. The route table is inside the VPC, and it shows that 172.30.100, which is the VPC CIDR, it's the local target, and the 000, which is the default route going to internet gateway. And this is the internet gateway. Internet gateway is technically connected to your VPC, and it's one of the AWS resources. We can't have that much access over it. It's just provided by the AWS, and we can attach our VPC to it and connect to the internet. And we can have just one internet gateway for our VPC. So you can see in this diagram, when we are going to implement our VPC, then we have to identify, or we have to tell the AWS that this is our CIDR range. Then we have to create different subnets inside our VPC within different availability zones with different ranges, and then we have to configure a route table for these guys and or connection to the internet through the internet gateway. And then you can run your resources, your virtual machines, let's say, inside each subnet. And I have one EC2 instance here and one EC2 instance here, and then they can have internet access if this subnet is internet accessible. There's another thing here that we can add, which is the security group. And as you remember in the AWS console here, actually we have a security group assigned to the VPC here, and I would like to tell you that we can have security group also assigned to each EC2 instances, so we can control who can access I mean, from which IP address technically, which protocol people can access to or instances. So this is one diagram. There are multiple other diagrams out there, but I would like to share this one with you. So another thing that I would like to emphasize in this page is, so as I said before, we can have a security group somewhere here. Let's say I have a security group here, which is technically controlling access to the VPC, and then we can have security groups to control who can access our instances. So let's say when a traffic comes through from the internet to the AWS resources to the VPC, then it's going to hit the security group for the VPC first, and then after going through the route table or based on the situation that we have, it's going to hit to the security group on each instances that we are running inside the AWS VPC and subnets. So this is it. This was just an overall overview of the VPC, and I will see you in the next lecture, which would be about the compute and how we can spin up an instance, EC2 instance or subnet. But before moving forward, I would like to highlight again that we are not going to do anything, and we are just using the default configuration in AWS, and you'll see how easy it would be to run EC2 instances in a default configuration. Okay, thank you very much, and we'll see you in the next one.